Hello everyone, this is Shubham. In this video, I'll be devising probability and this course is 0580. So let's start. The first question says rooms in a hotel are numbered from 1 to 19. That means total 19 rooms are there and rooms are allocated at random as guests arrive. First question is what is the probability that the first guest to arrive is given a room which is a prime number, right? So how many prime numbers we have from 1 to 19? That's 2, 3, 5, 7, 11, 13. 17 and 19. So total 8 are there. So 8 divided by, right? So this is our answer. Why divided by 19? Because total number of rooms are 19. Okay, let's see the second one. The first guest to arrive is given a room which is a prime number. So first guest has been already allotted with a room that is a prime number. So now total how many are left? Total 7 rooms are left which have prime numbers, right? So what is the probability that the second guest to arrive is given a room which is a prime number? So 7 divided by 18 because 1 is already given to the first guest. So only 18 rooms are vacant now. Out of these 18, one prime number is already been taken. So 7 by 18 is the answer. Okay. Let's see the next part. Second question, all 24 students in a class are asked whether they like football and whether they like basketball. Some of the results are shown in the Venn diagram. So those who like only football is 7, only basketball is 2 and both is 12 and 24, right? Total is 24. So when we add them together, 12 plus 2 plus 7, which is nothing but 19, right? And the total is 24, right? 12 plus 14, this is 21, sorry, my bad. This is 21, okay? So, but it is given that total 24 students are there. That means 24 minus 21, 3 students are such, those who don't like either of the sports, neither football, neither basketball. Okay. Now let's see the question. Universal set is the students in the class. Students who like football is F. B. How many students like both? So both means intersection. F intersection B. The answer is 12. How many students do not like either sport? So we have 24 minus 21, which is 3. They don't like either of the sports. Next is write down the value of n of F union B. F union B means everything of F plus 12 plus 2, which is 21, right? So n of F union B is 21. Total number of students in Fn. Write down the value of n of F complement intersection B, right? So F complement intersection B means only B, right? So how many students are there who like basketball? Only 2. The answer is okay. F complement means remove F, all right, from the union. So what is left out now? 2 and 3 is left out, right? So total 5 students are there. And then intersection with B, right? So intersection between 2 and 3 is 2 itself, right? In the same logic, P complement intersection F will be only F, right? F intersection B is only B. So keep this in mind. Next question. A student from the class is selected at random, right? So total number of students is 24. So we'll write it down. Total sample space. What is the probability that the student likes basketball? So how many students are there who like basketball? Right? 12 plus 2. Okay. 14 students are there, those who like basketball. So 14. So we can simplify this expression and write it as 7 by 12. That is your answer. Next one. A student who likes football is selected at random, right? So we are given that the selected student is the student who likes football. So I should know how many students are there who like football, right? So n of f is equals to 19, 12 plus 7. So the number of students who like football is 19. So this is our total sample space. And out of these students, what is the probability that the student likes basketball? Okay, so that means this is nothing but f intersection b. So f intersection b, that is nothing but 12 divided by 9. So that is your answer. Okay, next one. Two students are selected at random from a group of 10 boys and 2 girls. Find the probability that They both are girls. Okay. So fine. So total number of students is how many? 22. 10 plus 12 is 22. Okay. Now both are girls. So what is the probability that the first student chosen is girl? So total 12 girls are there divided by 22. Total number of students. This is the probability of choosing first girl. And then once the first girl is selected, now how many are left? Total 11 are left. Now we have to select the second girl from the remaining 11 divided by 20. So 11 twos are 22. And then here 3 fours are 3 7. Then 2 twos are 4. So final answer 2 by 7. It's a continuous process, right? They both are girls. So once the first girl is selected, remaining will be 11. All right. Next. One is a boy and one is a girl. So here, so the possibility could be the first one is boy and the second one is girl, or the first one is girl and the second one is boy. So what is the probability of choosing a boy? 10 divided by 22 multiplied by continuous process, mutually exclusive. So or means addition, right? Independent events. So add probability of girl is nothing but, now total how many girls are there? 12 divided by 21. Keep this in mind because already one boy has been selected. Now total number of students are how many? 21, right? They have to decrease one. Then probability of choosing a girl is 12 by 22 into. Now one girl is already chosen. Now how many girls are left? 11. So from total I have to subtract one. And boys remain 10. So 10 divided by 21. So this is nothing but 120 divided by 22 into 21 plus 120 divided by 22 into 20, which is nothing but 240 divided by 22 into 21. If we simplify this further, we'll get with 2 120 and then 11. Then with 3 sevens are 21, 3 fours are 40. So we get 40 divided by 77, and that is our answer. I hope you got this one. Next, fourth question. So there is a table given to us. Here we are given with the grades 1, 2, 3, 4, 5, 6, 7 number of students. So this is nothing but the frequency. All right. So what this table means is there is one student who got grade as 1. There are two students who got grade as 2. So frequency total, add them up. 1 plus 2 plus 4 is 7. 7 plus 7, 14. 14 plus 4, 18. 18 plus 8. Okay. And then 2. So total is given to us as the table shows the grade gained by 28 students in a history test. All right. So sum of the frequency is 28, we know. Write down the mode. Mode is what? Most occurring data entity. Right. So which frequency is the maximum? 8. Right. So they have asked write down the mode. So you don't have to write 8. Okay. Grades we have to write. Right. What is the data? 6. So what is repeating maximum number of time? 6 is repeating. Okay. So answer is 6 and not 8. 8 students got the grade as 6. Okay. So be careful with this one. Then second, find the median, right? So here n value is 28. So n is even, right? So n is even 28. So how do you find the median? 28 divided by 2, 14th term, and 28 by 2 plus 1, which is the 15th term. Now here I have to use the concept of cumulative frequency. So what is cumulative frequency? We have to add them. Okay, continuous addition of the frequency is cumulative frequency. Now let's see where 14th and 15th term will lie. So add them up. Here we get 3. Then 3 plus 4 is 7. 7 plus 7 is 14. Right? So here we get the 14th term. And then 15th term is lying here. Okay. 7. So till here we got 14. 14 plus 4 is 21. Okay. So now 14th term and 15th term. 15th term lies in this interval and 14th here. So the mid value 4 and 5. Okay. So 14th term gives us the grade as 4 and the 15th term gives us the grade as 5. Now median means there is only one mid value. So all we have to do is just add them together. 4 plus 5 divided by 2, which is 4.5. So 4.5 is the answer. Okay. Next part. Find the mean. Mean is nothing but the average. So how many students? Mean is nothing but total number of marks scored by the total number of students. So all we have to do is just multiply them and add them. 2 into 2 plus 4 into 3 plus 7 into 4 plus 5 into 4 plus 6 into 8 plus 14. Okay, whole thing divided by total number of students, that is 28. Okay, so now let's quickly add them. We have 1 plus 4. So let me write it here. 1 plus 4 plus 4 3 is 12. So plus 12 plus 7 4 is 28. So plus 28. And then we have plus 5 4 is 20. So let's write 20. And then 6 8 6 are 48 plus 14. So gives the total as 127. Now the answer divided by 28 gives us 4.54. Up to 3 significant figures, our mean is 4.5. This is the answer. Okay. So basically mean is nothing but the total marks obtained by 28 students. Right. So one student got 1 mark, two students got 2 marks, 2 grade. Right. So we have to multiply them because 2 students got it. Okay. So be careful with this. Let's see the next part. 2 students are chosen at random. Calculate the probability that they both gained grade 5. Okay. 2 students. So the first student, now there are 4 students. Okay. There are 4 students who got grade 5. How many are there? There are 4 students. So now the first child is chosen. So 4 divided by 28 multiplied by the next child, 3 divided by, okay, continuous. 2 students are chosen at random. Calculate the probability that they both gain grade 5. So 1 is already taken up. Right. So what is the probability of first child to get grade 5? 4 by 28. Then second one, because 1 is already done. So I have to subtract also. No? So 4 sevens are 28, 3 nines. So what do we get? 1 divided by 63. That is the answer. Next one. From all the students who gain grade 4 or 5 or 6 or 7, 2 are chosen at random. Calculate the probability that they both gained grade 5. Okay. So how many students are there total who got 4, 5, 6, 7 grades? 4, 5, 6, 7. Right. We know total is 28. So from total, you subtract this one, sum of this. So 3 plus 4, 7. Right. So out of 28 students, 7 did not get the grade as 4, 5, 6, 7. So those who got the grade as 4, 5, 6, 7, total students is how many? Total students, those who got grades as 4, 5, 6, 7 is 28 minus 7, which is 21. Now, out of these 21 students, how many got 5 as grade? So, there are 4 students who got grade as 5. So, the first child to get grade as 5 is 4 divided by 21 into, for the second child, 3 divided by 20. Remember, you have to subtract because one child is already selected. So, how many are left now? 3 students who got 5 divided by 1 from the total. Okay. So 3 sevens is 21 and then 4 fives are. So we have 1 by 35. 1 by 35 is the answer. Okay. I hope this is clear. Next one. Students are chosen at random 1 by 1 from the original 28 until the student chosen has a grade 5. Okay. So what do you mean by this state? Let's say first student is chosen, right? And he does not get 5 or he gets 5. Now what they are asking, calculate the probability that this is the third student chosen. Okay. So third student chosen gets a grade as 5. That means how many students are there who got grade as 5? There are 4 students, right? So remaining, those who did not get grade 5 is how many? 24. Right? 24 did not get grade 5. So the first student who did not get grade 5 is 24 divided by 28 multiplied by. The second student did not get grade 5 is 23 by 27 multiplied by the third student get grade 5. So 4 divided by 26. Okay. So this is our answer. Now understand it once again. They are given that students are chosen one by one from the original 28 until the student chosen has a grade 5. Calculate the probability that this is the third student. So the third student chosen gets a grade 5. So that means first and second student does not get grade 5. So how many students are there who got grade 5? 4. So remaining those who did not get grade 5 is 24. So 24 by 28. So one student is selected. Now how many are remaining? 27. So 27. And then how many did not get grade 5? Right. That is 23 because one student is already chosen. So 23 by 27 into 4 by 26 because now there are total 4 students who got grade 5. And how many are remaining? 26 because 2 are already taken. Right. So now we can simplify this and we can write 4 sevens is 28 and then we can write 3 3 nines are 27, 3 eights are 24 and then we can cancel with 2 2 fours are 8 and then 2 13, right? So what do we get now? 23 into 4 divided by 63 into 13. Okay, so let me write it here. 23 into 4 gives us 92 divided by 63 times 13. Okay, so 819. So 819, that is our answer. Moving on to the next question. A bag contains 7 green balls and 3 yellow balls. Sunny takes 3 balls out of the bag without replacement. Okay. So without replacement, that means find the probability that all 3 balls he chooses are yellow. Okay. So what is the probability that the first ball is yellow? So 3 by total. Total is 10. How much is the total? Total is 10. So first ball to be yellow, 3 by 10 into 2 by 9 into 1 by 8. Why we are subtracting? Because without replacement. Well, once the first ball is chosen, right, how many are remaining total? 9. And since the first ball is yellow itself, so how many yellow balls are remaining when the first ball is yellow? 2. And then second ball is also yellow, so only one yellow ball is remaining out of total 8. Okay, so this answer is nothing but 3 threes are, then 2 fours are. So we get 1 divided by 120. That is our answer. Next one. Find the probability that at least one of the 3 balls he chooses is green. Okay. So now see all the possibilities. We have to find at least one of the 3 balls. At least one of the 3 balls means what? At least means one green ball or 2 green balls or 3 green balls. Okay. So we have to find the probability that at least one of the 3 balls is chosen as green. So this is difficult. Instead, what we can do is 1 minus all yellow, isn't it? 1 minus all yellow will this one green, 2 green, or three green balls, isn't it? So we have already calculated all yellow balls, that is 1 by 20. So 1 minus 1 by 120, taking the LCM 120. So we have 120 minus 1, which is nothing but 119 divided by 1. And that's our answer. Next question. Question number 6. It says N is faulty, NF stands for not faulty, and there is a tree diagram given to us. The tree diagram shows the testing procedure on calculators taken from a large batch. Each time a calculator is chosen at random, the probability that it is faulty is 1 by 20. So for not faulty, it would be 1 minus 1 by 20, that is nothing but 19 by 20. Okay, so that means faulty. This is 1 by 20 and this is 19 by 20. Okay, so again faulty 1 by 20, 19 by 20. 1 by 20, 19 by 20. Okay, fine. Now, first part, write down the value of P and Q. P means faulty, so faulty is 1 by 20, and Q is not faulty, that means 19 by 20. That is our answer. Next, Two calculators are chosen at random. Calculate the probability that both are faulty, right? So both are faulty means FF, isn't it? So both are faulty means F and F. So 1 F and F, 1 by 20 into 1 by 20. Continuous process, and so 1 by 400. Very, very important. These are mutually exclusive, right? That means mutually exclusive means if one happens, the other one will not happen, or you can say they are independent as well. Okay. The probability of one does not affect the probability of the second one. Exactly one is faulty. So there are two possible cases as we can see here. If two of the calculators are chosen, the first one is faulty, the next one is not faulty, or the first one is not faulty and the second one is faulty. So we have two cases over here for exactly one. First one is faulty, second one is non faulty, or first one is not faulty and the second one is faulty. So faulty probability is 1 by 2, 1 by 20. Not faulty is 19 by 20. Ormans plus independent events. Okay. Not faulty is 19 by 20 into 1 by. So we have 19 by 200 plus 19 by 20 into 20, 400. So we have 38 divided by 400, which can be simplified as 19 by 2. So that's it. If exactly one out of two calculators tested is faulty, then a third calculator is chosen at random. Okay. Calculate the probability that exactly one of the first two calculators is faulty and the third one is faulty. Okay, so and means independent events. So continuation and multiplication, and stands for multiplication. Okay, so if exactly one of the two, so either we have the first one as faulty, next one is not faulty, and the third is faulty. So like this, or we could have had first one is not faulty because exactly one out of two is what they have said is tested as faulty, right? So first one is not faulty, second one is faulty, and then the third one is faulty. So these are the two cases we have here, right? Exactly one of the two calculator, first two has to be faulty. So let's see the probability of this 1 by 20. Not faulty is 19 by 20 into 1 by 20. Or 19 by 20, not faulty, 1 by 20 into 1 by 20. So we have to add them because or independent events. So we have this thing as 19 by 8,000 and this is also 19 by 8,000, which is 38 by 8,000 or 19 by divided by 2, 4,000. That is enough. Next one. The whole batch of calculators is rejected either if the first two chosen are both faulty or if a third one needs to be chosen and is faulty, right? Calculate the probability that the two batch is rejected. That means if you see clearly, this question D, we have already done. Where we have done? In part A. Sorry, part B1, right? Both are faulty. Two calculators are chosen at random. Calculate the probability that both are faulty, right? So either if the first two chosen are both faulty, and this is part B and the first part in the second part. Both are faulty. So what is the probability of both are faulty? B1 is, what is B1? 1 by 400. Okay. Or means plus mutually, I mean independent events, right? If a third one needs to be chosen and it is faulty. So we have done this in the part C, that is 19 by 4,000. So all you have to do is just add them together, 19 divided by 4,000. Now what is the LCM of 400 and 4,000? It is 4,000 itself, right? So I have to multiply here by, okay, so 10. So here we get 19. So 29 divided by 4,000. That is the answer. And if you want, you can do the 29 divided by 4,000, which is, sorry, 29 divided by 4,000 gives you 0.00725. You can write like this as well. Okay. So that is our answer. 29 divided by 4,000. Okay, next one. In 1 month, 1,000 batches of calculators are tested in this way. How many batches are expected to be rejected? Right? So this is frequency, probability of frequency, right? So what do? We know that a particular batch is rejected when the probability is 29 by 4,000. So probability of rejection is how much? Probability of rejection we already have calculated 29 by 4,000, and then 1,000 batches we have to check. So just multiply with 1,000. So this cancels out 1,000. So what do we have? 29 divided by 4. So let's see here, 29 divided by 4 roughly gives us 7.25. That means as a whole, 7 batches will be rejected. Right now, 7.25. You can also say or 8 batches because 0.25 is also more. Okay. So that is our answer. Frequency probability. How do you calculate the frequency probability? The probability of rejection, and we have to check for 1,000. So n into p. Okay. Fine. Next one. Question 7 says there are two bags as we can see here. Nadia must choose a ball from bag A or from bag B. The probability that she chooses bag A is 2 by 3. Now, what will be the probability of choosing bag B? Okay, I think that is what the question is. Okay, bag A contains 5 white balls, 3 black balls. So, total over here is 8. And the total over here is bag B contains 6 white and 2 black balls. So, total over here is also 8. The tree diagram below shows some of this information. So the probability of choosing bag A is 2 by 3. So the probability of choosing bag B would be 1 minus 2 by 3, which is 1 by 3. Now, why is it so? Because when we do an experiment, then the events associated with those experiment. Okay, understand this. When we perform an experiment, whatever events are associated with this experiment, okay, individual events. And what are those events? Event is choosing bag A and bag B. So these are called as exhaustive events. Total number of events associated with an experiment is called as exhaustive events. And the sum of the probability of exhaustive events is 1. Okay. So the event A is choosing bag A, which is 2 by 3. And we know that total number of events associated with this experiment is 2. Choosing bag A and bag B. So 1 minus 2 by 3 is 1 by 3. Okay. Using the same logic, white ball is 5 by 8. So 8 minus 5, 3 by 8. Because total has to be 1. These are exhaustive events. Now we have to find the value of R. This is what the first question is. Now let's see what is the probability of black ball from bag A. Okay, so total 3 black balls are there. So 3 divided by total 8. So 3 by 8. Now bag B. In bag B, 6 white balls are there, 2 black balls are there. So R is the probability of choosing a white ball. So 6 divided by 8. So black ball is 2, so 2 divided by 8. Therefore, we get the final answer. P as 1 by 3, R as 6 by 8, S is 2 by 8, and Q is 3 by 8. So this is our answer. Next question. Next question says find the probability that Nadia chooses bag A and then a white ball, right? Continuous process. Okay. So what is the probability of choosing bag A? 2 by 3 and then a white ball. So this. Okay. So 2 by 3 multiplied by 5 by 8. Fine. Probability of choosing bag A is 2 by 3 and then a white ball is 5 by 8, which is 10 by 24. Or you can write 5, 10 by 24 in decimal would be 10 divided by 24 gives us 0.42 up to 2 significant. Next. Find the probability that Nadia chooses a white ball. Okay. So there are two cases. White ball is there in bag 1 also and white ball is there in bag B also. So the probability of choosing a white ball from bag A There are two cases: choosing from bag A or choosing from bag B. There are two ways in which we can choose the white ball. So we have already done for the bag A, which is nothing but 10 by 24, and Ormond's add, okay, bag B. So where is bag B? Or is nothing but independent, right? The probability of choosing a white ball from bag B is independent from choosing a white ball from bag A. All right. So bag B is how much? 1 by 3 multiplied by 6 by 8. Okay. So we have 6 by 24, which is, or means add 10 plus 16 divided by 24, which is 16 by 24. Or you can say 4 4s are 16, 4 8s are, right? 4 6s are. So you get 2 by 3. That is your answer. Last question. Claude goes to school by bus. The probability that the bus is late is 0.1. Now, what is the experiment? Experiment is the bus is late. So, if the bus is late, there are two possibilities. Either it is late or it is on time. So, not late probability will be what? P of late is equals to 0.1. So, P of not late would be 0.9. This is clear from the first state. Second, it says if the bus is late, the probability that Claude is late to school is 0.8. If the bus is not late, the probability that Claude is late to school is 0.05. So the first question says calculate the probability that the bus is late and the Claude is late to school. So bus is late. So we have to find bus is late. So bus is late probability is 0.1. And then the Claude is late. So multiply 0.8, which is nothing but 0.0. That's that. Next part, calculate the probability that Claude is late to school. So he could be late in two ways. If bus is not late, but still he is late, and if bus is late, and then he is still late. So when bus is late, okay, then Claude is late, or bus is not late and Claude is late. So there are two possibilities. So 0.1 multiplied by 0.8, okay, or not late, bus is not late is 0.9 and then Claude is late. That probability is 0.05. So this is 0.08 plus 9 5 is 45. Then we have 0.3. So when we add this, we get 0.1125. That is that. Okay. Next, the last bit. The school term lasts 56 days. How many days would Claude expect to be late? So the probability of late is 125, and then 56 days is late. Out of 56 days, we have to find. So just multiply it by 56. Okay. So let's check here. 56 multiplied by 0.125 turns out to be 7. So 7 days he'll be late. So I hope the basic concepts of probability is clear to you. Stay tuned for more such questions and concepts. If you like this video, do share with your friends. Thanks for watching, everyone.